good morning. Uh, Today I am going to continue trigonometry chapter. In my previous class, that means in the previous video, yesterday, I have explained about the angles and applications. Okay, so the problems, numericals based on specific angles I have explained. And today I am going to continue the same next concept in the textbook. Next concept in the textbook is trigonometric identities. So before I go to trigonometric identities, I request you to subscribe my channel, and if you like my lessons, please share with your friends. And at the same time, because it is a public platform I am using, so I cannot speak to you. Personally, or I cannot chat you with directly. So if at all, if you are having any problems, please connect with me through my app, educational app, Dear Teacher. Go to Google Play Store and download Dear Teacher app and connect with me. Not only from the trigonometry, wherever you are, because in your class some other chapter may be going on, and exams might be coming in this month. So if you are having any doubts, you can happily ask me so that I can support you. So at the same time, don't forget to subscribe my channel. And in this channel, not only maths, you are getting even you are getting English lessons also. Not only English lessons. So English lessons also you will be getting, and science lessons also you will be getting. So have a happy learning. Let me take you to the trigonometry. So like algebra, we have identities like a plus b whole square. These are the identities: a plus b whole square, a minus b whole square, like that, and so on. So many identities are there. Identities are nothing but formulas. So how these formulas or identities are there in algebra, we have identities in trigonometry also. So let us understand one by one. So the first identity number 1, it is the relation between sine and cos. Identity number 1, it is the relation between sine and cos. Sine square theta plus cos square theta is equal to 1. It is just an identity. You can prove this also. Okay, it is a relation between sine and cos. Okay, so in the place of theta, you can write a, sine b, sine c, whatever letter you can have. So now for this, how to prove this, how you are going to get, you should take a triangle. Right angle triangle. Now in my triangle, angle B is 90 degrees. So, and I am keeping a theta at C. So then what is sine theta? Opposite side by hypotenuse. So opposite side is AB and upon AC. Same way, cos theta is equal to adjacent side by hypotenuse, which is equal to adjacent side is BC upon AC. Now in the identity, you take left hand side. This is left hand side. Let us take left hand side and substitute these values, and let us see whether we are getting a right hand side or not. So now I am taking left hand side. So the left hand side is sin square theta plus cos square theta. So in this I am going to put these two values. So then what happened? It is AB by AC whole square, and cos theta is BC by AC whole square. So then if I remove the square, AB square by AC square and BC square by AC square. Some students will keep the square only for AB. Wrong. Some students won't keep the brackets. Wrong. You have to keep the brackets, and once you remove the bracket, you should square both numerator and denominator. So then AC square denominator is same in both the cases. So AC square, and then AB square numerators can be added directly. So AB square, this square and this square. AB square plus BC square is nothing but AC square. This is the Pythagoras theorem. Pythagoras theorem. So then what happens? You can replace AB square plus BC square with the AC square. So then AC square by AC square, and cancel it, and you are getting 1, and this 1 is nothing but the right hand side. This is how you have to prove. This is the first identity. Okay, first identity, it is the identity between sine and cos. So let us go to second identity. Second identity. Here advantage is I can rub the board immediately, because if you want to copy, you will pause the video and copy. And second identity, it is the relation based on the tan theta. So 1 plus tan square theta is equal to secant square theta. So it is the relation based relation with tan theta. So if you take 1 plus tan square theta is equal to secant square theta. Okay. So then for this also same type of proof is to be applied. So take a right angle triangle and name it A, B and C, and B is right angle. B is right angle is to be applied. So take a so then here also theta I am keeping at C. You don't need to keep theta also. You can, in the place of theta, you can write C tan square 1 plus tan square C is equal to secant square C. So here tan theta is equal to opposite side by adjacent side. Opposite side by adjacent side, that is nothing but AB by BC. And in the same way, secant theta also, secant theta is nothing but hypotenuse by adjacent side. Reciprocal of cos. Hypotenuse is AC by BC. Now let us take as usual left hand side. Left hand side is nothing but 1 plus tan square theta. So in the place of 1 plus tan square theta, 1 is 1 only. In the place of tan theta, let us write AB by BC. So AB by BC Because it is tan square, I'll write AB square by BC square. Don't forget to keep square for both numerator and denominator. Again, BC square is LCM. So then what happened? BC square plus AB square. So as we know that Pythagoras theorem, the Pythagoras theorem says AB square plus BC square is equal to AC square. So in the place of AB square plus BC square, we can write AC square. But here BC square plus AB square is there. Both are same. A plus B, B plus A. Both are same. So in the place of numerator, I am going to put AC square. So denominator is same. So this what I will do. Here AC by BC. AC by BC is nothing but AC by BC is nothing but secant theta. Already I have written here. So then what happened to AC square by BC square? AC square by BC square, because it is square, then you will be getting a square. So secant square theta. This is nothing but right hand side. So this is how the second identity get proved. Now let us go to the third identity also. Third identity. Third identity, it is given on cot theta. 1 plus cot square theta is equal to cosecant square theta. Cosecant square theta. So then here same, you take the diagram, take a right angle triangle and name it. This time I will make it a PQR just for change. Okay, all the diagrams I have kept ABC. Now in this PQR, Q is 90 degrees. Okay, then what is the Pythagoras theorem? PQ square plus QR square is equal to PR square. Side square plus side square is equal to hypotenuse square. So now here cot theta. Theta where I should keep? I will keep here. Always base side theta is always better. So cot theta is equal to adjacent side by opposite side. Adjacent side is QR and opposite side is PQ. And cosecant theta is equal to hypotenuse by opposite side. These definitions you have to remember very well. Huh? So hypotenuse is nothing but PR and opposite side is nothing but PQ. Now as usual, let us take left LHS of the identity. LHS of the identity is 1 plus cot square theta. So then 1 is 1 only. In the place of cot square theta, this value will be replaced. QR by PQ. So QR by PQ, because it is square, we will put square for both numerator and denominator. So again the LCM is PQ square. So here PQ square plus QR square you will be getting. So numerator can be replaced with the Pythagoras theorem. Okay. So then in the place of numerator I can write PR square. So denominator there is no change. Okay. PR square. So but PR by PQ. PR by PQ is nothing but cosecant theta. Okay. So then PR square by PQ square is nothing but cosecant square theta. This is nothing but right hand side. So this is how the third identity got proved. So 3 identities I proved. So let me have all the 3 identities together. So the first identity, sine square theta plus cos square theta is equal to 1. The second identity 1 plus tan square theta is equal to secant square theta. And the third identity 1 plus cot square theta is equal to cosecant square theta. So don't think that identities are only like this. This identity can be written like this also. Okay, 1 minus sine square theta is equal to cos square theta. 1 minus cos square theta is equal to sine square theta. The same thing, I have sent sine square to the other side. So then cos square theta is equal to 1 minus sine square is equal to 1 minus. So even these two are also identities only. So don't think only this is the identities. From the identity only we got this. Same way here also the same. So secant square theta minus tan square theta, whenever you get this you can put 1. Because if I send tan square to the right hand side, secant square theta minus tan square theta is equal to 1. In the same way, secant square theta, if I send 1 to the other side, secant square theta minus 1, which is nothing but tan square theta. So same way, I need not tell you, you will automatically write. So cosecant square theta minus cot square theta is equal to 1, and B, here cosecant square theta minus 1 is equal to cot square theta. So don't think that only identities are just only these two things, these three things. This is identity, and remaining things are sub-identities, or you can have corollaries also. So I hope you have understood. Now based on the next exercise, the problems based on these three identities. Okay, I request all of you, whoever is watching my video, please practice these identities and proofs. Remember them very nicely, and then tomorrow in my next class we are going to do the applications. Have a nice day. Once again, I request all of you to subscribe my channel and share this video to your friends. At the same time, if you want to connect with me, download the Dear Teacher app. Okay, you just download, and then I'll put you in the 10th class batch. So there I can help you. You can connect with me. You can clear your doubts with me. Have a nice day. Bye bye.